Assalamualaikum, good day and hi. Today we are from Group 6 are going to present about our signal assignment titled Convolution.
For task 1 part 2, we have to determine the signal zt, which is the summation of signal x1 and x2. If we look at the graph, we can see that in x-axis there is the value of t, and in y-axis there is the value of the amplitude is given. So when we are taking t is equal to -1, for x1 the amplitude is 0, and for x2 the amplitude is 1. So for this is basically the summation of amplitude here. So zt is equal to 1. When we're taking t is equal to -0.5, x1 is equal to 0 and x2 is equal to 1, so z2 is equal to 1. When we're taking t is equal to 0 as well, the zt is equal to 0. When we're taking t is equal to 0.5, the amplitude of xt turns from 0 to 1 and x2 is 1, so the zt will be 2. When we're taking t is equal to 1, the amplitude in x1 is 2 and x2 is 1, so zt is equal to 3. So when t is equal to 1.5, xt is equal to 1 and x2 is equal to 0, so zt is also 1. When we're taking t is equal to 2, x1 is 0 and x2 is 0 as well, so zt is equal to 0. So now we got all the new values of amplitude for zt. So we're gonna plot all the values of amplitude in x-axis, in y-axis, and the time in x-axis. That's how we can get the summation of two signals x1 and x2, which is zt. Thank you.
After that, we use MATLAB to check whether the calculation is same with the result of MATLAB. By the addition of both signals, the MATLAB shown the graph same with the calculation part.
For task 1 part 3, we need to calculate the yt using the convolution operation. So first, we need to replace the t in s1t by tau and replace the t in s2t by t minus tau. Then we calculate the yt by using the formula. For case 1, we consider that t plus 1 is less than 0, so t is less than -1. Since there is no overlapping between two signals, so the yt is equal to 0. Then for case 2, we consider that t plus 1 is between 0 and 1, so t is between -1 and 0. Since there is overlapping between 0 and t plus 1, so we integrate from 0 to t plus 1 and we can get the result. For case 3, we consider that t is between 0 and 1, and from the graph, there is an overlapping between 0 and t plus 1. Therefore, we integrate from 0 to t plus 1 for case 3. For case 4, we consider that t is between 1 and 2, and from the graph, there is an overlapping between t minus 1 to 2. Therefore, we integrate from t minus 1 to 2 for case 4. For case 5, we consider that t is between 2 and 3. Since there is an overlapping between t minus 1 and 2, therefore we integrate from t minus 1 to 2 for case 5. And for case 6, we consider that t is more than 3. Since there is no overlapping, therefore yt is equal to 0. Summarize all the cases and we can get this graph, which is the same compared to the graph we get by using MATLAB code.
This is the recording of convolution of both signals. The result shown is same with the calculation part, thus it is verified by MATLAB.
Next, for task 2 part 2, where zt is equals to gt plus ht, first of all, for the manual calculation, we can take some of the points of the x-axis, which is t, where t is equals to -1, 0, 1, and also 2. So for t is equals to -1, gt is equals to 0 and ht is from 0 to 2. Then we can get zt is equals to 0 to 2. When t is equals to 0, we get the value of gt is equals to 1 and ht is from 2 to 0. And then we get the value of ct where zt is equals to 3 to 1. Next, when t is equals to 1, we get gt is equals to 2 to 0 and ht is from 0 to 1. Then we can get the value of ct where zt is equals to 2 to 1. And then next, when t is equal to 2, gt is equals to 0 and ht is from 1 to 0. And then we can get the value of ct is 1 to 0. And then we take all the values from the manual calculation and we can plot it. And we can get the graph as shown given for the graph zt is equals to gt plus ht.
After the calculation part, we check the result by using MATLAB also, and the result shown in MATLAB is similarly with the calculation part.
So for task 2 question 3, the question asks us to find the multiplication of ht and gt. So for this one, we use the convolution operation to find it, and the formula is integration from negative infinity to infinity of h tau times g t minus tau d tau. First, we need to convert t to tau first. For ht, we just directly convert to h tau, and then tau equals to negative 1 to 0, h tau will equals to 2, and from 1 to 2, h tau will equals to 1. For gt, we need to do time reversing and time shifting first, and we will get g negative tau after time reversing and g t minus tau after time shifting, and we will get the graph like this one, t plus 1, t minus 1, and since gt is equals to 1 plus t, so when g t minus tau, the equation will become 1 plus t minus tau. To find yt, h signal will stay at its position and g signal will move from left to right. So now we start from case 1 where t plus 1 is smaller than negative 1. At this point, g signal and h signal are no overlapping. So after doing the integration, we will get 0 for t plus 1 smaller than negative 1. So now for case 2 where t plus 1 is in between negative 1 to 0, we need to do the integration. As we can see that the two signals are overlapping each other. So for the integration, you can see that the overlapping part is from negative 1 to t plus 1. So our limit for integration is negative 1 to t plus 1. And h tau, just now we already mentioned, in negative 1 to 0, the h tau is 2. And then the equation for g t minus tau is 1 plus t minus tau. After doing the integration, we will get t squared plus 4t plus 4. Case 3 where t plus 1 greater than 0 and smaller than 1 is using the same method, but this time the limit is become negative 1 to 0 because the overlapping part is negative 1 to 0, and then we will get 2t plus 3. Okay, so for case 4 where t plus 1 is in between 1 to 2, you can see that there are two different overlapping parts. So when we do the integration, we also need to do for the two parts and add up together. So for the left side one is when t minus 1 to 0. At this interval, h tau is equals to 2, and then we do the integration like previously. And for the right side is integration between 1 to t plus 1. And at this interval, the h tau is equals to 1. So after doing the integration and add up together, we will get half t squared minus 2t plus 3. The next for case 5 where t plus 1 is in between 2 to 3, the overlapping part is 1 to 2. So we do the integration, and remember that the h tau is equals to 1 at this interval, and we will get yt equals to t minus 1 over 2 when t plus 1 is in between 2 to 3. Okay, so for t plus 1 in between 3 to 4, our overlapping part is from t minus 1 to 2. So we do the integration and we will get yt equals to negative 1 over 2t squared plus t plus 3 over 2. And lastly, when t plus 1 greater than 4, we will see that the two signals are not overlapping each other anymore. And we will get yt equals to 0 since they are not overlapping. Okay, so finally we combine all the equations we calculated previously. These are all the equations we get at their own interval, and we transfer all these equations into the graph. We will finally get our yt graph as shown as the figure.
Finally, the coding of convolution of both signals is done. By comparing the graph showing by MATLAB, the result of calculation part is same with the result in MATLAB. Thus, it is also verified.
That's all from us. Thank you.